All right, we have been using all kinds of different methods to find solutions to equations. So we've been factoring. We've been using our calculators. We've been looking at graphs and tables. We have done the square root method. We have done so much. I bet you can't believe there's more, but there is. And there's even more after this. It's just the gift that keeps on giving. So here's what we're going to do. We're going to talk about completing the square. So completing the square is kind of the best one because it's like we're actively trying to break the rules, okay? And the rules are, we don't want to factor, okay? Like, right, we took that factoring test. It wasn't good. We didn't like it. So completing the square is a way to cheat factoring, to cheat ourselves. So we're going to like, oh, I should factor that, but I'm going to scooch on past that. I'm going to use the square root method instead, okay? So I tried to show one of my classes this without using the tiles. It didn't work out, so let's take a look. So this equation that I have modeled is 4x squared plus 12x, right? So all I have is 4x squared plus 12x. And I need to figure out, first of all, I'm going to be doing a strategy called completing the square, right? So what square exactly am I completing? This is the square that I'm completing. Now, I took my 4x squareds and my 12x's and I arranged them as close to a square as I could get them while following the rules of tiling. But here's the thing. It's not a complete square because I'm missing some stuff. What do I need to add to complete this square? Well, what I need is 9 ones, okay? So that's the equation that I have written down now. So I'm going to, really quick, I'm going to zip on back over here. I have 4x squared plus 12x. And then I've got equals 5, right? So let's take a look at the camera. Where's the camera? I don't know where the camera is. Oh, it's just still here. Okay, so I've got 4x squared plus 12x equals 5. That's what I have modeled up there. Now, if I look at the model, whoopsie, where are you? If I look at the model, I want to make this a perfect square trinomial. So the question you may be saying is, why do I want to make this a perfect square trinomial? Well, because if I can make it a perfect square trinomial, I can turn it into a square root method problem. Now, why do I like the square root method? Because the square root method doesn't have any like something adds up to 5 but multiplies to give. I don't care. I'm not trying to, this is not like quiz show. I just want to get the answer. I want to stick the math in my calculator and I want to get an answer out. Okay, so I'm tired of all this bozo factoring nonsense, all right? So this is what I'm trying to do. I'm trying to cheat. I'm trying to cheat. So I don't want to have to deal with factoring. I want to do some math. So what we're going to do is we're going to complete the square, okay? So I am going to turn this, what I've got here, instead of subtracting 5 from both sides and then factoring it and then getting some weird number, I'm going to turn this into a perfect square trinomial and write it as a squared binomial. I know it's a lot of words. Let me show you what I'm going to do. So in order to complete this square, right, I got to add 1, 2, oh, thank goodness it's snapping, 3, 4, I know this could not be more excruciating. I probably should have planned ahead. Maybe I should have paused, but we're just going to talk about it while I drag these tiles. 6, 7, 8, we're so close, 9, yay. And now I have a square. This is a square. It is x is 2x plus 3 by 2x plus 3. It's the same on both sides. This is a square. Okay? So, what did I do? I added 9, right? So let's see. How did I get 9? Okay, we'll get to that in a second. So I took my 4x squared plus 12x. I added 9. Now, here's the problem. This is no longer a balanced equation because remember, if I want to, oh, that would be great if I could copy them. No, I can't. If I want to, can I copy them? I'm sorry, this is not the time. So if I add 9 to one side, I got to add 9 to the other side. Otherwise, my equation is no longer equivalent. So if you look back here at what I have written down, this is not equivalent to this. This is 9 heavier. So think about it. I have a scale, right? I added 9 pounds to this side, but I didn't add 9 pounds to this side. So the whole, whoop, the scale, like, this side got really heavy and this side got real light. I'm not in balance anymore. So if I want to stay balanced, I'm sorry, that was -5, by the way. I have to add 9 to this side, too. What does that allow me to do? Well, it allows me to write this perfect square trinomial that I created, that I handcrafted myself. It allows me to write it as a binomial squared. Take the square root of the first term, take the square root of the last term, put the sign in front of b in front of it. -5 plus 9 is 4. This I can solve easily using the square root method. Okay? So the whole point of this, again, is that I have factored so much stuff, you guys. I'm tired of factoring. I think, okay, that wasn't supposed to happen. I think we're all tired of factoring. Evan's tired of factoring. So, what we're going to do now is, we're going to not do that. We're going to cheat. So let's get our notes out and let's talk about what that looks like. These are actually not my notes. Somebody left these notes in my classroom, and I couldn't find any more notes. So whoever's notes have stars all over them, I think we all know who these notes are. I've got your notes. All right, so here's what we're going to do. This is a whole lot of information. Now, first of all, this part down here, it's theoretically possible you could get an equation that already is a perfect square trinomial, and then all you got to do is write it in factored form and use the square root method. Okay? So this is how we find, this part down here is how we figure out if something is a perfect square trinomial. Now, in class, we didn't write multiply a times c, take the square root, multiply. We just wrote 2 square root of a times c is how we find b. Okay? So what we were doing is we were checking, is it a perfect square trinomial? You'll never have to add a b value. That's just not what we're going to do. But what we are going to do here is I want to show you how you can figure out what b should be, so you can see if you already have a perfect square trinomial, and then you can figure out how to write it as perfect square, as a binomial squared. Okay, so I have 2 times the square root of 4 times 9, which when I put it in my calculator works out to 12. So I should have 12 x's there. To write it as a perfect square trinomial, as a binomial squared, I take the square root of the first term, which is 2x, the square root of the last term, which is 3. It has a minus sign in front of b, so I put minus there. Okay? And that's all we're going to do to write these as a binomial squared, which is mission critical for using the square root method or completing the square. Now, to find c, literally all we're doing is we're doing this backwards. Instead of multiplying by 2, we're going to start by dividing by 2. Instead of taking the square root, we're going to do the opposite, which is squaring it. Instead of multiplying by a, we're going to divide by a. And I'm just going to tell y'all right now, I had a whole bunch of people today who were like, but what? You're just going to have to memorize it. You're just going to have to memorize it. We memorize processes all the time. This is a process you're going to have to memorize, okay? So since I'm looking to figure out how many squares I need to complete this square, I'm going to take b, which is 12. I'm going to divide it by 2, which gives me 6. I'm going to take that answer and I'm going to square it, which gives me 36. I'm going to take that 36 and divide it by 9, which gives me 4. Okay? Some of you are like, but why? If you want to bust out the tiles and prove it to yourself, you can. I have tiles here. But in order to make this a perfect square trinomial, I have to add 4. Mathematically, I've just done it. So to write this as a binomial squared, I would put 3x plus 2. All right, so that's the why, that's the how. Let's do a couple of problems. So first of all, the first thing I'm going to do is I'm going to divide by the greatest common factor as long as it doesn't make my quadratics term not a perfect square. So what does that mean? Let's take a look at this one. I accidentally put 10 instead of 12, so let's write that as 12. Okay? If I look at this problem, and we're not going to write this down, but we're having a conversation right now. 9x squared, so it says here, I'm going to use completing the square when ax squared is a perfect squared. We don't usually use it when b is odd, but we can. Okay? So if I look at this, 9x squared is a perfect square. But there's a greatest common factor. Now, what if we take out that greatest common factor of 3? I have 3x squared plus 2x equals 4. Good for me, I took out the square root, and you know what I did? I completely botched my opportunity to cheat. Because this isn't a perfect square. 3x squared is not a perfect square, so I can't use the square root method anymore. So we're going to rip that off and throw it away. We don't want to do that. That's a terrible idea. So in this case, we want to keep the greatest common factor because we can't do completing the square if we don't have that one, that as a greatest common factor. But let's look at this one here. For this one, if I divide everything by the greatest common factor, which is 2, this wasn't even eligible because 2x squared is not a perfect square, but now I have x squared plus 10x plus 10 equals 36. Now that's a perfect square. Now I can use completing the square. Okay? So again, I kind of have to like pick and choose whether or not I'm going to complete, what I'm going to do here. I have to kind of decide, but I decide based on whether it's going to give me a complete, like a perfect square when I'm done with it. Okay, so let's look at this one. The next step says get all x's on the left and numbers on the right. What that means is I need to have my quadratic and linear terms on the left, and I need to have my constant term on the right. The next thing says rewrite with spaces. So like, what does that mean? Well, let me show you. I'm going to write x squared plus 4x plus blank equals 5 plus blank. So this blank is going to make this thing a perfect square trinomial. This blank, excuse me, I have to sneeze. Excuse me, sorry about that. This blank is because if I add it here, I got to add it over there too. All right, so what am I going to add? Well, remember this process, just the more you write it, the more you're going to memorize it. I take b, I divide it by 2, I get 2, which I square, which gives me 4, which I divide by a, which is 1, which gives me 4. That means I got to add 4 to both, or add 4 to everything to make this a perfect square trinomial. Okay, so now I'm going to write it in binomial squared form. Well, the square root of x squared is x. The square root of 4 is 2. I have a plus there, so I'm going to put a plus there. 5 plus 4 is 9. I am all ready to do my square root method. So I take the square root of both sides. I have x plus 2 is 3. X plus 2 is negative 3. Because remember, I have 2 square roots, a positive and a negative root. So then I just solve for x. So, and somebody asked me today, like, why are you solving? Well, because I don't want to know what x plus 2 is. I want to know what x is. The solution is x, so I got to know what x is. So I have to actually isolate the x and solve this equation so I can figure out that x is 1. Okay, I have to have 1x when I'm done. I'm trying to figure out what x is, not 3x or x plus 2. So these are my 2 solutions. Okay? Now, the other thing that you might see, and again, you might see one of these, in which case you're just going to factor them just like we just did. But in this case, what I see is I've got something else there. Like this already looks like a quadratic. But that doesn't mean I can't complete the square. Like, I'm here for the cheats, right? I'm not here for being honest. So, if I can get rid of this 1, then I'll have a place I can put my space. Okay? Because I know this isn't a perfect square trinomial. Because 2 square root of 1 times 1, that's 2. This is a negative 4. This is not a perfect square trinomial. But if I subtract 1 from both sides, it's going to look like that. Okay, so then I'll have x squared minus 4x plus something equals 6 plus something. Remember, now I'm already all set to make myself a perfect square trinomial. So I take b, 4, I divide it by 2, which is 2. I square it, which is 4. I divide by a, which is 1, which gives me 4. It's not always 4. It just happened to be 4 this time. But 4, which is what I have to add to both sides. All right. Now I rewrite this as a binomial squared. And I add this. Now, here's where it gets a little ugly. That is not a perfect square. It is not going to be a pretty answer like the square root of 9. But you know what? Who cares? I have a calculator. I ain't afraid of no irrational numbers, okay? So I'm going to square root this side, square root this side. I get x minus 2 equals, where'd my calculator go? Come back, best friend. Come back, best friend. Okay, so square root of 10, oh no, what happened there? Square root of 10 is, that nonsense, is 3.16 and negative 3.16. It's okay, I have a calculator, I'm not scared. So I get x equals 5.16 and I get x equals negative 1.16. And there's my solution. Again, no biggie. All right. Let's do this last one down here, because this one has something other than, hopefully I have to add something other than 4. But you know what? I don't know at this point. Let's see what happens. Okay, so for this one, I'm already in, like, I've already got my x's on the left, my number on the right. Now, again, I do have a greatest common factor, but like we talked about earlier, I don't want to take this greatest common factor out, because then this won't be a perfect square and I can't cheat. Okay, this is the only time I'm going to tell y'all it's okay to cheat. Okay, so you got to go with this. All right, so I'm going to take b, wait, what am I doing? Oh yeah, I take b, which is 6. I'm going to divide it by 2, and it gives me 3. I'm going to take 3 and square it. That gives me 9. I'm going to take 9 and divide it by a, which is 9, which gives me 1. So apparently, I have to add 1 to both sides. Okay? And that's okay. I just add what I got to add. I just do with the math. I let the math guide me. Okay? So I'm going to write this as my binomial squared. Square root of 9x squared is 3x. The square root of 1 is 1. I got a plus there, so I put a plus here. 12 plus 1 is 13. Also looks ugly, but again, my BFF's got my back. My BFF's not going to let me down here. Okay? So I'm going to take the square root of both sides. I get 3x plus 1 equals. Okay, what is the square root of 13? Got my back, BFF? You sure do. It's 3.61. It's also negative 3.61. Okay? So I'm going to subtract 1 from both sides. I get 3x equals 2.61. And then I got to divide that by 3. And I get 0.87. So x equals 0.87. Okay, great. There's one of them. We'll do the same thing here. I'm going to subtract 1 from both sides. Okay, I got that. I'm going to subtract 1 from both sides, and I get, okay, so 3x equals negative 4.61. I'm going to divide both sides by 3, and I get x equals negative 1.54. Again, it's not pretty, but you know what it is? It's done. Okay? So, this is completing the square. I hope you enjoyed our presentation today.